Okay, good morning. This is Mr. Handy Clement. Thank you for being with us for such a long time, and thank you for continuing to subscribe us and share our content. Okay, it has been a busy year. Okay, and I still hope that we can move together. Okay, so today we are talking about exothermic and endothermic. Okay, we have here window, and then we have on the other side exhaust. Okay, for the beginning, it's quite hard to focus. No worries. Okay, after I use my I use a pen, then it should be okay. Okay, so endothermic is that, for example, there is some energy here. Originally, the energy. Okay, the energy is here, and maybe allow me to make it higher so that they can focus better. Because maybe it's too close. Okay, so this is energy. For example, we have 500 K joule after reaction. Okay, this item contains 900 K joule. So can you see the energy contained of this? For example, I give you the idea of this. This energy of the butter that melt into the watery liquid butter. Okay, it's still the same butter, but the energy become higher. So a lot of heat is taken in. So in between here, a lot of heat is taken in. Heat. So this is endothermic. So this is contain only 500 K joule, but this one already 900 K. This is just for example. I'll give you a big number so that you can calculate. This is actually a physical reaction, not a chemical reaction. The purpose of this is just to show you the difference in the energy. Okay, today's purpose will be focused on the chemical energy. Okay, so now, right, we have the street subject. Okay. For the endotermic, we have the street subject. It's very hard to focus on with the color pencil. Okay, so that, okay. So this is a popular street, which is citric acid. Plus the sodium, hydrogen, carbonate will become a sodium citrate. Plus the carbon dioxide plus water. Okay. So when you eat this in your mouth, you feel cool, right? Cool. Why? Because here, for example, I give you again the number. This is 500K energy here, and then here you have 900K. So this increase, right? So due to this, a lot of energy needed. A lot of energy needed. So where does the energy? These two, when they are dry, they cannot mix together. So when you put in your mouth, okay, this is your tongue. Okay, and then you have the saliva. Saliva here and there. Okay. So when these streaks mix with your saliva, water, and then they'll react. When they react, they will take in a lot of the heat from the surrounding, from your tongue. Okay, so you'll feel like, oh, loss of the heat. So you feel cool. You feel cool. Okay, other are just like the, okay, not only the melting subject, and also then you have the number 3, which is cooking. When you cook and eat, okay, when you cook and eat, okay, so the eggs from the watery one will become solid, right? The eggs initially in the liquid will become solid, and then this happens that change their structure and texture. And also taste, right? Yes. Next will be heating limestone. Another one, 1, 2, heating limestone. Limestone is made of the calcium carbonate. Okay, this is calcium carbonate. Okay, CaCO3. When limestone is heated, it breaks down to form CaO and carbon dioxide, CO2. This CaO, calcium oxide, we call it a lime. Lime is to make what? To make bricks, to make plaster. to make glass and paper. When the water is mixed with this lime, okay, a slaked lime is made to use to neutralize. Okay, for example, if this is a land, if this is two acid, okay, we can mix this CaCO2, CaO together, so that to become a slaked lime. Okay, slaked lime. And then this slaked lime we can pour here. Pour, okay, to neutralize the acid, so that this acid no more. Okay, or you can to treat the sewage to make it harmless, or in the food processing. Okay, slaked lime. Okay, in our place, I think then the noodles is treated by the slaked lime. Okay, large amount of slaked lime also converted into the lime using a machine called Kira. Okay, so the last one will be the photosynthesis. So the leaf actually take in the energy from the sun. Okay, to convert the CO2 plus H2O. This is not balanced yet. I just to become food and oxygen, and then in between a lot of energy is coming in. So this low energy CO2 will become a high energy food here. Now we shall go back to our exothermic. Okay, exothermic is what? Exothermic is something that loss of heat. Can you see this is a gain of heat? So this one should be loss of heat. Initially, for example, I give you an example. Okay. Originally, the heat is 800 K. After the reaction, for example, the energy will become 600 K. So from 800 to 600, it means that there's a drop here. Okay. So when you burn some charcoal, I draw some charcoal here. It's made from wood. So there's a burning here. So this is 800. Okay. So when it's burning, after burn, then it will become an ashes. So no more already. Now this is 800, this is maybe 600. So there is a loss. So the energy, can you see the frame? The energy is given out. Energy is out here. So the surrounding will become hot. Okay. So just now this one, the surrounding is cool. It's cooling. Okay. Cools down. It cools down. Sorry. Cools down. Okay, but this one surrounding is hot. Surrounding is hot. Okay. So because if you are here near to this, then you feel like very it cools you and you feel very cold. But here you feel very hot because your energy is taken away from you. But this one energy is given to your finger. So number one is burning. You shall have the second one. Oh, but before that, we shall do the burning thing first. Okay. Burning is the, or we can call it burning or combustion. Okay. So it's the C plus O2 become a CO2. Is it okay? Yeah, there you can see. Okay. Okay. So another one. Oh, there is a so-called incomplete combustion. Okay, incomplete combustion. Okay. Besides that, we also have this other thing, which is hydrocarbon plus oxygen to become a carbon dioxide and water. Another one will be methane. Example, an example of the hydrocarbon is methane, which is a natural gas, plus oxygen will become a CO2 plus water. However, sometimes the oxygen is not enough. So what happened? Let's see. It will become a carbon monoxide. Okay. Where it's insufficient oxygen to support the complete combustion, so it becomes a carbon monoxide. Okay. When you have this carbon plus, now it's O2, right? Okay, but if this one is O, how? Okay, so this is CO2. But if this is O, and then this you have carbon more, 2 carbon plus O2, then it will become 2 carbon monoxide. So each one, this one, each C have O2, but this C only have O1. This is so-called incomplete combustion. So carbon monoxide is colorless. This is colorless. Okay. Odorless. No smell. But they will reduce your ability to take in oxygen, the blood to take the oxygen around the body. So you will, this person will be died from breathing CO. Okay. Then how we measure? Okay, after we're talking about endothermic and exothermic, how we measure the the energy change? Number one, for example, you have a tripod, and then you have a split burner, and then it's a wick, all right? Okay. And then you have lighted up. You have the beaker with water. And then you have the thermometer. Okay, this is the way of measuring energy in the field. So this is the so-called simple calorimeter. So if you want to change one methane, you can use methane. Then you calculate how much Celsius increase and how much of the fuels have been used. Another one is called a specific design calorimeter for the food. Okay, this is a simple one. Now, before we move to the food one, we should do the thing with the proper one. Okay, so we have another meter. Look like this. We have a special design calorimeter. Okay, but that one I think I will prepare it next a drawing on coming lessons. Okay, so we should look at other exothermic reaction. Number one is respiration. As compared to photosynthesis, this is just opposite. There will be the glucose in the food plus the oxygen will become a CO2 plus H2O water. So in between here, a lot of energy will be released. Okay, so we can use the energy so that to run, to breathe, to think. Okay, next one will be the oxidation. Okay, when the substances burn in air where with oxygen, this is called oxidation. So oxygen is just like the burning. Okay, but oxidation may not have the frame, you know. Oxygen combined with the element in the substance form the compound in this example. So incomplete combustion will cause the carbon in fuel and to be oxidized with carbon to become carbon monoxide. A complete combustion resulted in the carbon being oxidized to form the carbon dioxide. Another oxidation is rusting. This is a water vapor on the air from the air condensed on the iron and steel and form a film of the surface of the metal. Oxygen dissolve in the water and react with the metal to form an iron oxide, which is a rust. Okay, rusting. This is iron oxide. This is a brown flakes of rust, which break off from the surface and expose more matter to the oxygen dissolved in the water. The iron or steel continue to produce rust until it has completely corroded. Okay, so the formula is that iron plus oxygen become iron oxide. Okay. Okay. Okay, that's all for today's class. I think that's all for today. Nothing much. Okay. So the important thing is that you must know that endothermic is that the whole thing, even though the same, the mass is there, but the inner energy is from increase. But exo is that the same thing, okay, will decrease, okay? If they are the same thing, that means it's reversible easily, we call it a physical change. If this is very hard to reverse, then we call it a chemical change. Okay, that's all for today. Thank you for joining me. Hope you enjoyed this sharing. Bye.